All right, the next family is the alkynes. This is very similar to the alkenes. We're just adding in, instead of an -ine ending, we're adding an -ine ending. But all the numbering rules, all the branches, everything that we've learned so far still applies. We're just changing the ending. So for the alkynes, the general formula is CnH2n minus 2. And just like we had to take off 2 hydrogens to form the double bond in the alkenes, the alkynes have a carbon-carbon triple bond, which means we've had to take off another 2 H's, and that's why the 2n minus 2. So these are also unsaturated, just like the alkenes are. Both the alkenes and the alkynes are considered unsaturated molecules. But all of the numbering rules, everything else applies. We're just going to have that -ine ending. So let's go ahead and jump right into the examples. This is a 2-carbon parent with a triple bond. So this would be an eth-ine for that one. Don't need a number because either way it's carbon 1. So that's it for this one. Okay, next example. Now I have a 4-carbon parent. So now I have to include the number. This is a bute. And the triple bond I would number from right to left in this case to give me the lowest number. So this would be a bute-1-ine. The triple bond is starting on carbon 1. Okay, let's jump to the next one. Okay, same thing on, oops, try and go back here for a second. Okay, there we go. So we've got a 4-carbon parent. Now the triple bond, is in the center. So this is still a bute because it's 4, but now it's a bute-2-ine. Okay, hopefully that makes sense. If any of this is not making sense to you, make sure you let me know. Send me an email or message me. All right, the next one, now we look at adding in some branching. So remember, my parent has to be the longest chain that contains the functional group. So in this case, this one's a little bit trickier. Remember that in line diagram, it's every end or bend. So in this case, I have an end, a bend, but I also have an end of the triple bond here and an end here. So the triple bond tends to form is a linear shape, and so sometimes in the line diagram you'll see it like this, and you may not, if you're not being careful, you may miss that middle carbon where the triple bond ends there. So don't miss that. So this is a 4-carbon parent. So I have a bute-1-ine as my parent, and then for my branch I have a 1-carbon branch, which is a methyl again. And in this case, remember that my functional group is most important. So this is 1, 2, 3. So this will be a 3-methyl bute-1-ine. All right, now what if we had to draw them? Instead of me giving it to you and see if you can name it, try to draw this out. Now that would all depend on how you chose to try to draw this, whether you chose structural, condensed, or line. And maybe I'll show you all 3 just so that you can get some practice. So in a structural diagram, I always start with the parent. So this is a bute, which means 4. So 1, 2, 3, 4. I know it's a bute-1-ine. So that means there needs to be a triple bond that starts on carbon 1. So there's my bute-1-ine parent. And then it says a dimethyl bute-1-ine. Now this is a little tricky because it doesn't give me the normal 2 numbers that should go with dimethyl. But remember, if they don't give you those numbers, it's because there's only a certain place those branches can go. And in this case, if we look at this, I know I can't put a branch on carbon 1 because that would just become part of the longest chain. That would become part of the parent. I can't put a branch on carbon 2 because that carbon is already forming 4 bonds. So it doesn't have room to form any new ones. So let's get rid of that. I also can't put a branch on carbon 4 for the same reason I can't put it on carbon 1. That would become part of the parent. So the only place that those 2 methyl branches can go are on carbon 3. There's going to be a methyl branch there and a methyl branch there. Now keep in mind, if this is a structural diagram, I should be making sure that every carbon has all 4 bonds. So we'll draw in that. This carbon's already full. This one has 3, so it needs 1 more there. So there would be a structural diagram of dimethyl but-1-ine. If I wanted to draw that same thing in condensed, that first carbon has 1 H. That next carbon has no H's because it was already full. Oops, put that one in the wrong spot. Because it was already full from the 3 bonds with the first carbon and the 1 bond to the next one. The next one also had no hydrogens because it's full of bonds to other carbons. So we got a CH3 up there, the first methyl, and a CH3, the other methyl down here, and then another CH3 over here. So that would be it in condensed. We just take the H's and we condense them in to show what carbons they're attached to. If I was to draw this in line, I would start with my triple bond, and I would remember that that forms a linear shape. So there's my triple bond, there's the next carbon after that. So now I have 3 carbons, and then there would be my 4th. Now I'm not going to be super picky about that linear shape though. So if you happen to draw it 1, 2, 3, 4, and then you drew in that that was a triple bond, I would accept that. That's fine. In reality, it's probably going to look like that top one with the linear shape, but I won't mark the bottom one wrong, so don't stress out about it too much. And then because I have to draw a dimethyl, I would need to have 2 methyl branches coming off of that 3rd carbon. Now the direction doesn't matter too much. I've done it like this because that tends to reduce crowding. But if by chance you drew one of them up like that, that's fine as well. I just tend to draw it where it's kind of spaces things out. Remember from Vesper and Chem 20 a little bit, they don't like being close to each other. They want to spread out as much as they can. But I'm not going to be super picky on whether you drew it up or down. As long as you have it attached to the correct carbon, you'll be okay. All right, so that's it for the examples from the alkynes. If there's anything there that you found tricky or you had trouble with, please let me know.